Good morning, students. I hope all of you are doing quite fine, well with your studies. I welcome you all to the online classes in physics for standard ninth. Today, students, I would discuss a very important topic. For the past few classes, we have been discussing about Newton's laws of motion. After finishing them, today I would discuss something about free body diagram, which is a very important tool that will enable you to solve the numerical problems pertaining to these topics of Newton's laws of motion easily. So there are some concepts, deep concepts involved. First, before proceeding to solve some numericals, let us try to understand those points which are must for everybody. Firstly, whatever problem is given, try to draw a figure for that. For example, on my right side, you can see I have drawn a figure of a wooden block resting on a table which is fixed. So this is a table, it is fixed. On the table, we have a block whose mass is mass m, and on this mass, somebody is applying some force F, because of which this mass will slide over this table with some acceleration A. Just a simple situation. For example, this is the table, this is the mass, and somebody is pushing it like so. So it accelerates in that particular direction. First step is to choose a system, and that system you can represent by a point. So in this figure, I will choose this mass as a system, and this block of mass small m I'll represent by a point. Different parts of this system must have same acceleration. Now suppose this is the block, this point, this point, this point, this point, different points of this particular block, they will move together. Okay. It's not that the front part will have more acceleration, the back part will have less acceleration. All these parts will have same acceleration. So I can choose this block as a system. This table is fixed. Fixed means its acceleration will be zero, speed will be zero. So I should not take table plus mass as a system, because the table has a different acceleration and the block has a different acceleration. So we should not take table plus block as a system. It's important. Then second step, indicate forces with the help of arrows acting on the system. What is my system? My system is this block. Then you think of the forces which are acting on this block. You think of the agents which are exerting force on this block. So can you guess? The first force that comes to you, our mind, is this F. Somebody is pushing this block with some force F. So there is a force F towards right. So in diagram, we will represent this force with the help of a arrow, an arrow. Is there any other force or not? This mass must be influencing some gravitational force. Earth is pulling it downward. So there is a force exerted by Earth on this block. This force, we write it as mg. So let me, in the chapter gravitation, I will read in details about this particular thing. So for the time being, you remember students, if there is a body whose mass is m, then Earth pulls it downward with a force that we call as its weight. Mass and weight are two different physical quantities. If there is a body of mass something, then its weight is the force with which that body is attracted towards the earth. Earth is pulling me with some force. Whatever force the earth pulls me downward, that force is my weight. Okay. So this mass m is pulled down by the earth with a force. That force we'll call it as weight. And this weight value. So weight is a force. I am saying. What is this weight? Weight is the force exerted on mass on the body by whom? By the earth. So it is a force. Force is equal to Newton's law says, second law, force is mass times acceleration. This acceleration is due to gravity, so we write m times g. So weight of the body is that force we will write as mg. So whenever in your diagram you find some mass, put gravitational force is equal to how much? M times g. Okay. So I have written here mg. So one force was F, second force was mg. Is there any other force? Yes. Since this block is resting on the table, suppose this is the table, this block is resting on this table, the table also offers a force. Newton's third law. The block is pressing the table. Newton's third law says the table also presses the block. So I don't have to draw the force which the block is exerting on the table. I have to indicate force which is exerted on the block. Who is exerting that force? The table. So the table will exert some force on this block in upward direction. This block is pushing the table downward. Newton's third law, table will push this block upward. Such a force we call as normal reaction. These are very basic things but are important. That's why I'm going a bit slow. Each and every term you must understand. There is no confusion for this force, but these things might be new for some of you. So understand these two concepts properly. There is no other force, we say. So one force is the force which I am applying, which the person is applying. Other one is gravity in downward direction, and other one is the normal reaction exerted by the table on the block. When you draw this figure for beginners, those who are beginning the problems pertaining to these topics, always ask who is exerting the force on this system. What is my system? My system is this block. This is my system. Always ask who is exerting this force. Some person. Who is exerting this force? The table. Who is exerting this force on the system? Earth, gravity. So always ask who. The answer of that who must be the surrounding. It may be a person, it may be a string, it may be earth, it may be something else. But it should not be the mass itself. That I have written here. Do not include in your diagram the forces that the system itself exerts on its surroundings. For example, this mass is pushing the table downward like this. So this force should not be included on in the diagram because we are drawing the free body diagram of the system. My system is not stable, my system is the block. That's why we have to indicate only those forces which are acting on the block by anybody, by the surroundings. We will not include the forces which the system or this block exerts on other objects. This is the most crucial point in the free body diagram. Okay. Now, after you do this, one more step I should write here. You divide the forces into horizontal and vertical if possible. Horizontal and vertical. Now, in all questions, we may not have this situation horizontal and vertical. So, one more step I'll use here. So, this is 2A, then 2B. Divide the forces in two categories in directions perpendicular to each other. Number one category along the direction of motion, and number second category perpendicular to direction of motion. And these two forces, they will not be related to each other. Now let me try to explain the meaning of this. Segregate or divide the forces. Now here there are three forces. You divide them into two categories. And these two categories are in two different directions. Those two different directions are perpendicular to each other. One direction will be along the direction of motion and other will be perpendicular to the direction of motion. This motion may be actual motion, or it may be impending motion. Impending motion means, for example, I am pushing an almirah, but the almirah is not moving. Such a motion can be called as the body remains at rest because of some friction. So in that case, instead of motion, it's impending motion. If the almirah moves, it would move in some particular direction. This block tends to move towards right. So this is horizontal direction. So this is one category, and perpendicular to this is other category. So this force is in horizontal direction. That means it is in the direction of motion of the block. And these two forces are perpendicular to the direction of motion of block. These two different directions which are perpendicular to each other should be treated separately. Don't try to mix them. Okay? So two categories you write for. Let me write here only for motion uh, along the direction of motion of block. Along the direction of motion block, there is only one force. So now we have to use Newton's second law. Newton's second law means total force is on the body is equal to its mass into its acceleration. Now in horizontal direction, what is the acceleration? A. What is the force? F. I am using this formula. In the direction of motion, the only force is F. So I'll write F is equal to mass of the body M, acceleration of the body A. That's it. Then what is other category? Perpendicular to the direction of motion. That means this one. This is perpendicular to the direction of motion. Acceleration is in this direction. So in the direction which is perpendicular to acceleration or perpendicular to direction of motion. Now, what are the forces here? One is normal reaction in upward direction, other one is gravity mg in downward direction. This force is mg. Since they are in opposite direction, the total force should be n minus mg or mg minus n. So the net force F net that I'll write as n minus mg. Why I wrote minus? Because they are in opposite direction. So total force is equal to mass. What is the mass of the body? Same m into acceleration. Now think students, this block, how is it moving? It is moving in horizontal direction like this. Is it moving upward or downward? No. In vertical direction, there is no motion. So there is no acceleration. That means A is 0. Acceleration in the perpendicular direction. In this direction, there is no acceleration, so I will write 0. So it becomes 0. If this becomes 0, that means n minus mg is equal to 0. So n equals to mg. So a very simple example I have discussed for a book or for a block moving on a table on application of some force. But the steps are important. Now, if we have understood this it's okay. Otherwise, I would suggest you to pause this video. Please go step by step and then proceed further to discuss the questions. One more thing I would like to discuss. So as I told about one force, that is gravity, for a body of mass m, the gravity is the weight and that weight is equal to m times g. There is another force about which I should discuss, that is tension. Tension I'll denote it by T, capital T. It is the force which is developed in a string when it gets stretched. Suppose there is a roof on which you tie a thread. At the bottom of the thread you tie some load. Then this string becomes taut and then this string will develop some force that we call as tension. Always remember, tension always pulls. The direction of tension at any point on a system will be such as that it will tend to pull the system. Always it will pull the system. It will never push the system. This is the mass. Suppose its mass is m. I want to draw free body diagram of this mass. So I have represented it by a dot. It is at rest. Rest means its acceleration is 0. Now what are the forces acting on this mass? I have to choose a system. I have chosen the system. Now I have to indicate forces acting on the system. One will be gravity in downward direction. So gravity is acting in downward direction. How much will be the force? I have told weight is equal to m times g. What is the value of g? We will study afterwards that small g is equal to 10 meters per second square near the surface of Earth. Actually, it's 9.8 meters per second square. Is there any other force? There must be. Why I am telling there must be? Because if there is no other force, this mass should move in the direction of mg, but it is at rest. That means there must be some force which is balancing this force, and that force must be in upward direction. Who is exerting that force? The string. What is the name of that force? Tension. Is this string pulling this mass or pushing this mass? It is pulling it upward. As I told, tension always pulls. So remember these things, students. For a body of mass m, its weight will be always in downward direction mg. If there is a string which is stretched, the direction of tension will be such as to pull the system. A string can never be used to push a body. It can be used to pull a body. I can tie a string to a block and I can pull the string and the string will pull the block. But I cannot push the block using that string because the moment I try to push, the string will become loose and tension will become 0. Remember, tension is 0 in case of loose string. And then we have to draw the free body diagram and we have to apply Newton's second law of motion. Net force is equal to mass into acceleration. With these important concepts, let us now try to solve some questions. First question. Suppose there is a pulley and on that pulley we have a string wrapped over it. This is a light pulley and it is very smooth. There is no friction. On either side of it, we have attached some masses. Let this mass be m2, let this mass be m1, and it is given that m2 is greater than m1. Okay. We have to find. Now, if you release the system from rest, what will happen? Because this mass is heavy, it will go down, and this mass will go up. What will be their acceleration? That you have to find. So find acceleration of m1 and m2. And number B, tension in this string. Okay, let us try to discuss this question. First of all, we will follow these steps. We will draw the free body diagram. Now there are two masses, so we will draw free body diagram of M1 and M2. So M1 I am drawing here. And M2 here. M1 will go up or down. It will go up because this is heavy. It is heavy, so it will go down. This will go up. So M1 will go up. So its acceleration will be A in upward direction. M2's acceleration will be A in downward direction. Now we have to indicate the forces acting on the system. On M1, what are the forces? One is gravity. Gravity always acts in downward direction. Mass is M1, so gravity will be M1 into G. Now this string I have told it will always pull. So the string will pull this mass in upward direction with some tension. That tension I am writing as T. This mass again it will be pulled down by earth with a force that we write as m2 times g, and the string will pull it although it is moving down. But remember, I have told string can never push, string will pull only. If string is pulling, why it is moving down? Because gravity is more than tension. T. Please understand it. There are two forces. One is gravity, one is tension on mass 1. And there are two forces. One is gravity in downward direction and one is tension on this mass in upward direction. So for both the bodies, we have two forces. After writing the forces, now these forces are along the direction of motion. So no need to choose two different directions. Now we have to use Newton's second law. So for M1 and for M2, let's write the equations. For M1, first you see where is the acceleration. Acceleration is upward. Since acceleration is upward, the force in upward direction, take it as positive. You have to find a net force in upward direction. So T is upward, M1G is downward. So since acceleration is upward, I told T we should take as positive. Okay. At the same time, M1G is opposite to the direction of acceleration. So we will take it as a negative. So the total force becomes T minus M1G. This is total force, that is F net, is equal to what is the mass? M1. What is the acceleration? A. Equation number 1. Now let us apply the same rule for M2. For M2, one force upward, one force downward. But where is the acceleration? Acceleration is downward. Since acceleration is downward, so we should take the downward force as a positive and upward as negative. So the equation will become M2G minus T. This is the net force, and that is mass times acceleration. Understand this, these equations. Here we write T minus M1G. Here we write M2G minus T. So this will depend upon the direction of acceleration. Now we have got two equations. We have to solve these two equations to find tension T and acceleration A. A and T we have to find. The first thing that we can do, suppose this is equation number 1 and this is equation number 2. You add these two equations. If you add, you can see what will we get? T minus M1G plus M2G minus T. Left hand sides we have added, right hand sides also you add. So M1A plus M2A. So T and T minus T will cancel. So this implies here G you can take common, M2 minus M1. And here A you can take common, M2 plus M1. So therefore A becomes how much? The difference of masses by sum of masses into G. This is the value for acceleration. Now knowing the value of acceleration, we can easily find tension. For finding tension, what we will do, we will put the value of A in equation 1 or in equation 2. Let me rub this part. So let us quickly put the value of A. So put A in suppose equation 1. So we will get T. T equals to, this will come to the right hand side, M1G plus M1A. So M1 we can take common, G plus A. So M1 we can take common, we will get G plus A. Now put the value of A. A is equal to how much? M2 minus M1 by M2 plus M1 into G. Again G we can take common. So here we will get M1G and 1 plus this much. So take the LCM. So M2 plus M1. So M1 and M1 will cancel, minus M1. So therefore T is equal to M2 plus M2 is 2M2. So M1 is also there. So M1, M2 G by m1 plus m2. So this is the answer to this particular question. So this is the expression for acceleration and this is the expression for tension. Please try to do this question again. Stepwise. First step, choose the system. Second step, draw the free body diagram. Indicate the forces acting only on the system. Then use Newton's second law, net force is equal to mass into acceleration, and then solve the equations which you have got. If you are able to do it yourself properly, then you have understood the concept. Now you are ready to proceed for other questions. So let's try to see some other questions. Suppose there is a smooth table. So this table is smooth. On this table there is a block whose mass is m1, and there is a pulley. String runs over this pulley. One end of the string is tied to this block mass m1 and the other end is tied to a block whose mass is m2. The system is held at rest. Now you have to answer that if the system is released from rest, then what would be their accelerations? So this will obviously move down, and this is attached to this string, so string will pull this mass towards right, so it will move to the right with same acceleration a. So let us draw the free body diagram for m1 and m2. First m1. On m1 there is a force due to gravity in downward direction, that is m1 times g. Then there is tension in the string and that acts towards right, so that is T. Then there is a table, so this mass is pushing the table. Newton's third law, table will push this mass upwards, so there will be a force that we call as normal reaction. Now for m2, you see gravity will pull it downward, so this will be m2 times g. And the string will pull it upward. Always I have told string pulls, so there will be tension T in upward direction. Okay. Then acceleration of m2 is downward, so a is downward and its acceleration is towards right. Let us first write the equations for m1. For m1, as I have discussed, for writing the equations you have to consider two different directions. These two directions should be perpendicular to each other. One of the directions should be in the direction of motion, other direction should be perpendicular to the direction of motion. Here the motion is in horizontal direction. So along the horizontal direction, so I am writing horizontal motion or horizontal direction, and other one is vertical direction. In horizontal direction, how many forces are there, students? There is only one force, so total force becomes T. We have to apply this force, this formula, net force is equal to mass into acceleration. So net force is T is equal to mass. What is the mass? m1. What is the acceleration? A. This is the equation, as simple as that. In vertical direction, there is no acceleration. Acceleration is zero. So net force is how much? N in upward direction, m1g in downward direction. Since they are in opposite direction, we will put a negative sign, and the total force is mass m1 into acceleration, but acceleration is zero in this direction. So this becomes zero. So this implies what we will get? N equals to m1g. So these are the two equations which we have got for mass 1. For mass 2, so by the way, what we have to find in this question? We have to find same tension in the string and acceleration of the bodies. These two things we have to find. Now for M2, M2 free body diagram I have drawn here. So there is a force downward, there is a force upward direction, but acceleration is in downward direction. Since acceleration is downward, the downward force due to gravity we will take as positive. So equation will become m2g positive minus t is equal to mass into acceleration. Now what is the mass? Mass is m2. And what is the acceleration? Acceleration is a. So a. Now we have to solve these three equations. So we don't need this equation. So our purpose will be solved using these two equations, equations 1 and 2. Put the value of t from 1 in 2. So from 1 and 2, m2g minus t. Instead of t, how much we can write? m1a is equal to m2a. This will go that side. So m1a plus m2a equals to how much? m2g. And therefore acceleration will become m2g by m1 plus m2. So this is the acceleration answer for this particular question. I hope the solution is clear to you. Now knowing the acceleration, you can easily find the tension. So to find the tension, you can use any of the equations, but I think it will be easier to use equation number 1. So put A in equation 1. So we will get T is equal to M1 into A. M1 into A. A is this much. So this is the answer. M1 M2G by M1 plus M2. Is it clear, students? So these are some important numericals. I will end up today's discussion with one more numerical and the last one. And then if you have understood them properly, you will be able to solve the numericals on your own. I would suggest you to do some numericals yourself. I'll give you in the assignment link. Please visit the school's website to see the assignment link. Next question. Question number 3. Suppose this is a smooth surface and there are 3 masses of suppose 1 kg, 2 kg and 3 kg. Let me name them as M1, M2 and M3. And a force F is applied towards right on this 3 kg block. And this force F is given to be suppose 24 newtons. Okay. You have to find the acceleration of the system and the tension in these two strings. Find number A, acceleration of the system, and number B, tension in the two strings. There are two strings you can see. Let this string have tension T1, and here this string has tension T2. So you have to find T1, you have to find T2, and you have to find acceleration of the system. So when this force F acts on these masses, these 3 masses will move towards right with some acceleration. That acceleration is A. Solution. The first step is very important in this particular question. Here we will choose M1 plus M2 plus M3 as a system. Now where I had written these steps, I hope you have written them in your notebook. Please see there I have written different parts of the system must have same acceleration. Now see, since they are tied with the help of a string and the string is light, mass is not present. So the acceleration of 1 kg block and 2 kg block and 3 kg block will be same, A and A. They will move together. Since they are having same acceleration, hence we can take them to be a same system, single system. So the free body diagram will be like so. I represent this dot for M1, M2, M3 combined. So what will be its mass? m1 plus m2 plus m3. On this system, you have to indicate the forces. Now, one important statement, let me tell you, which I missed in those steps. Do not include internal forces in the free body diagram. Actually, you can include, but it will just make the things complicated. They will cancel. Now, what is internal force? Internal forces, it is the name given to such forces which are exerted by one part of the system on the other part of the same system. So if I choose this as a system, this is one part, this is one part, this is one part of the same system. So this is pulling this 2 kg, 2 kg is pulling this 3 kg, 2 kg is pulling. These forces are within the system. Forces within the system should not be included. Outside the system, whatever forces are there, only that are to be included. The more you practice the numericals, the better will be the concepts. Now, here M1 plus M2 plus M3 is the system. What are the forces? Forces which the part of the system are exerting on one another, that we will not include. So tension T1 and T2 should not be included here because they are internal forces. Outside the system, which are the forces acting? One is force F, that is 24 Newton. Other one is gravity. Gravity, you know, m1 plus m2 plus m3 into g, and the ground will offer a reaction. These three masses will push the ground. Ground will offer a reaction, Newton's third law. That reaction force is, suppose, L. So these two forces, in vertical direction there is no motion. In vertical direction there is no motion, acceleration is 0. So as we have done earlier, n will become equal to m1 plus m2 plus m3 into g, which we don't need, so I will not calculate it. In horizontal direction, we'll apply Newton's second law. Net force is how much? F. Total mass is how much? m1 plus m2 plus m3 into acceleration. Acceleration is in right direction. A. This will give the value of A. A is equal to F by m1 plus m2 plus m3. What is the value of F? 24. And m1 plus m2 plus m3, 1 plus 2 plus 3, that is 6 kg. 24 by 6, this will give us the value of acceleration as 4 meters per second square. So all these three masses, the entire system will move to the right with an acceleration of 4 meters per second square. Now we have to find T1 and T2. For that, we will choose suitable systems. For finding T1, that means tension in this string, we will choose M1 as system. So let's quickly see what we get. So this is M1. M1 is having acceleration in right direction. So who are exerting forces on M1? One is the string. That force is nothing but tension. In which direction? Right direction. And the value is how much? T1. Then what else? Gravity, M1g, normal reaction, suppose I name it as N1. So understand carefully. Earlier we had drawn the free body diagram of the three objects taken together as a system. Now I am drawing the free body diagram for M1 only. So for M1, these things are now not a part of the system. Our system is M1. So this string is external to this system. That's why I have included this force T1. See, don't confuse here. You should not write 24 Newton. 24 Newton, remember, it is acting on M3. It is not acting on 2 and 1 kg masses. Then why are they moving? They are moving because of these strings. If you cut this string, do you think after applying force of 24 Newton, this will move? No. So it is moving not because of 24 Newton, but we say because of the tension in this string. As we have discussed earlier, these two forces will cancel because in a vertical direction there is no motion. So there is only motion in horizontal direction, and in horizontal direction we will write the equation For horizontal direction, net force, that is T1, is equal to mass into acceleration. Mass is m1 into acceleration is a. A value is how much? 4. M1 is how much? 1. So 1 into 4 Newton, that is 4 Newton. So T1 we have got. Next, to find T2, you can choose either 3 kg as a system or 2 kg as a system. I will take 2 kg as a system and I will solve it. Please try to solve the same question by taking 3 kg as a system and see to it whether you are arriving at the correct answer or not. So now we choose M2 as a system. Suppose this is M2. So gravity will act in downward direction, M2G. Normal reaction will be there, upward direction, M2. Now this M2 is tied to strings on either side. Both these strings will try to pull M2. So this string will pull in this direction. That pull is the tension T2. And this string to its left will try to pull it towards left. So this tension will be in opposite direction, that will be T1. In vertical direction, there is no motion, so these two forces must cancel. They will balance each other. So N2 is equal to M2G. But in horizontal direction, there is acceleration. Where is this moving? It is moving towards right with acceleration A. So the acceleration is towards right. So what equation you should write? Net force is mass into acceleration. So what is net force? Net force in the direction of acceleration. Acceleration is towards right, so we will take T2 as positive, T1 as negative. So T2 minus T1 is equal to mass. Mass of the body is M2 into acceleration. T1 actually I have rubbed the board. T1 we have already calculated. T1 was how much? 4 Newton. So put the value of T1, you will get T2. So T2 is equal to T1. T1 will go that side. T1 is 4 Newton plus M2A. M2 is how much? M2 is 2 kg. Acceleration A is how much? 4 meter per second. This gives the answer as 12 Newton. So I'll stop here, students. I hope you understood the concepts which I wished to convey to you. Please practice some more numericals based on them, which you can find in the assignment link in the form of a PDF. So it's all for today. We'll meet again in the next class. Till then, take care, read well. Thank you, students.